In this paper, we present our method for simulating realistic whitewater effects, such as the ones seen in these lapping waves. Notice that as the waves crash against the rocks, bubbles form, rise to the surface, and develop into captivating foam patterns. Our bubbles are represented as Lagrangian particles that are two-way coupled with the surrounding grid-based fluid through buoyancy and drag forces, and we use an inverse cubic radius probability distribution to mimic the bubble sizes found in typical ocean wave breaks. This allows us to achieve organic separation of bubbles of different scales and pleasing swirling effects caused by collective behavior. The importance of coupling is further demonstrated when we compare our two-way coupled simulation guided by a bulk fluid to bubbles simply influenced by the same bulk fluid unidirectionally, which is typically done in a common production setting. We also show the fluid domain allocated sparsely around the bubbles in our guided setup. As the blue bubbles reach the water surface, we use a simple heuristic to transition them into the white foam representation, where they naturally adhere to the surface using our manifold advection method. We employ a constitutive model of wet foam and discretize it using SPH. With only a handful of parameters such as foam cohesion, cohesion radius, and viscosity, we are able to achieve a number of unique looks. We have used our guided bubbles and foam approach to produce a number of compelling simulations. Here, spinning propellers create a characteristic circulating fluid motion that is cashed out. A secondary simulation of guided bubbles and foam is then added to create realistic-looking patterns. A giant submarine emerges from underwater, creating a massive wake. Emission of bubbles is done using our proposed aeration metric, which compares local surface tension forces with the fluid Reynolds stress. The result is a single, physically plausible emission heuristic that significantly simplifies the process of generating an emission volume. Tiny waterfalls and backdrafts of a mountain river would not look the same without swirling bubbles and detailed foam shapes. Whitewater effects help amplify the features of the underlying bulk fluid motion, making the final result much more attractive. We return to the rocky beach video from before and show it without the water surface to emphasize the dynamic shapes and motion more clearly. Here we show the bubbles in blue and the foam in white. Each component of our method is important to the final look. By taking a holistic approach that tracks bubbles from emission all the way through to forming interesting foam patterns on the surface, we achieve a more convincing, connected whitewater look that other methods struggle to produce without significant expert parameter tuning. Thank you for watching.